2024 made history for the warmest winter on record in the US. And globally, we saw the warmest January and February ever recorded. As Earth's average temperatures rise, data shows us that winter is the fastest warming season in most US regions. So why do we keep having deep freezes? And why do they keep happening in places like the Deep South?
I'm in Huntsville, Alabama, and we got snow.
And January was extremely warm. 15 low temperature records were broken in Kansas, which is sort of ironic. And it also makes me wonder, how should we prepare for these complex impacts as our climate continues to change? In this episode, we're gonna dive into a new study that makes the future of winter in a warming world much clearer. And to understand winter in the US, we're gonna look at one of the most extreme winter storms in modern history. The 1993 blizzard that was dubbed the storm of the century.
Here we have ours from March of 1993. The 13th opens with the line, "What most called the worst winter storm in Alabama history struck Friday afternoon and lasted until midday Saturday."
There's no way people can get around, right?
No. If they're at home now, they need to stay there. If they're not, they need to be trying to get there.
Really remarkable for any time of the year, even more so for the last week of winter. 13 inches in Birmingham makes it the biggest snowstorm of all time.
As global temperatures rise and winters warm, we're actually seeing some interesting good news. Deaths from cold temperatures are decreasing. And this makes me want to understand the storm of the century more, because although a fact like this may lead one to believe that massive winter storms like the storm of the century may be a thing of the past, recent data says otherwise. To understand why that is, we're going to go back to 1993.
Flowers were blooming, the daffodils were out. It was the time of spring. We were up in the 70s on many days, and everybody was thinking about spring break and going to the beach.
So when meteorologist James Spann saw what looked like an intense winter storm coming late in the season, he wasn't really sure how to break the news.
Do you have the guts to go on television and forecast a catastrophic winter storm in mid-March? And quite frankly, I didn't have the guts to do that 5 days in advance. I didn't believe it.
Back in 1993, weather models weren't as good as they are today. But this particular system was very hard to dismiss. The ingredients included a deep area of low pressure in the Gulf of Mexico and record cold temperatures dropping down from Siberia.
It was forecasted 5 days ahead of time. Now, back in 1993, our forecasts weren't very good after 3 days, but this was such a big event that even the weather forecasting models were able to pick it up.
But I was able to see some of the model forecasts of the storm before it came ashore. The thing that amazed me about it was the model stayed pretty consistent on the position and the strength of the storm.
With high stakes of an extreme winter storm like this, James decided to go on air.
So about 3 days out, we went on television and said we could have a major winter storm this weekend. And I don't think anybody listened. And I don't blame them. I wouldn't listen either. This was the middle of March.
This was the middle of March, and yet we had a tremendous Arctic outbreak of cold weather all the way down to Alabama.
The storm hit Alabama the night of Friday, March 12th, 1993.
Winter Storm 93 blows into Alabama.
And it was truly the storm of the century. It blanketed parts of the state with 20 inches of snow, and Birmingham saw 13 inches.
You had a true blizzard conditions here in a southern state, and that's pretty remarkable.
By Friday morning, every office from Georgia northward had called every single county, telling them about this storm and what would happen.
Oh, good, a snowstorm.
This was not just an Alabama situation. This was one that affected the entire eastern part of the United States.
It snowed from Mobile all the way up to Maine. That's a storm.
This storm was so memorable that even our experts from previous episodes couldn't help but share their experiences.
I remember walking around Central Park. We had about 13 inches in total. It was beautiful. It looked great, but when you try to step on it, you didn't actually sink into the snow at all. It was literally concrete.
I was actually living in the Washington, D.C. area. Had about a foot of snow, but it also turned to rain too. Everything was almost like concrete when it ended.
I was very popular in my neighborhood because I still had my South Dakota snow shovel. So I was able to help a number of neighbors.
And our colleague Darren at PBS even has a shirt to immortalize the storm. But what were the consequences in a place like Alabama, which is so unaccustomed to snow?
Down in town, it was just a nightmare.
We had upwards of over 500,000 people with no power. We had to move into a hotel because we had no power for 1 week. Travel was impossible. The National Guard had to be called in. You had women that were going into labor that had to get to the hospital to deliver their babies, and they couldn't do that.
The two nurses met us halfway.
Some people needed medication to live. This was a life-death situation.
And remember, this was 1993. There were no cell phones, and most were without power. So radio became critical.
The local radio stations became a lifeline. They stopped playing music, they stopped their regular format, and they just took phone calls from people that had urgent needs. People were listening, and maybe somebody a few blocks away heard that call and they had that medication and they could walk it over there.
Snow's over, but the damage isn't.
There were over $5.5 billion in damages, equivalent to $11.6 billion today. Over 270 people died across 13 states. Nearly every interstate from Atlanta northeastward closed, and almost every airport on the East Coast closed at some point due to the severity of the storm, representing the most weather-related flight cancellations in U.S. history up until that point. And from Florida to Maine, nearly 10 million people and businesses lost electricity. But again, this was 1993. Our climate has been warming steadily since then, so one would think that we're in the clear for big winter storms, right? Ironically, a new paper is challenging that assumption, and we'll get into that, but first, we have to understand how this super cold outbreak happened.
The jet stream took on this roller coaster shape or configuration. It went way up to the north over Alaska, and then came very quickly down on the other side of the Rockies, southward, all the way into the Gulf of Mexico. So that's about as extreme extent of the jet stream as you'll really ever see.
The jet stream is a high altitude, fast moving air current that can carry very cold air from the Arctic. And shortly before the storm of 1993, the jet stream dipped south over the eastern US.
The jet stream is generally on the boundary of that cold air. And so the jet stream was very far south. And it is along the jet stream that these storms form. And so because that bulge of cold air was all the way this far south, the storm formed on its edge and then drifted to the northeast.
As the jet stream carried cold Arctic air into the south, it collided with warm, moist air from the Gulf of Mexico.
You had the coldest air of the northern hemisphere interacting with basically some of the warmest air in the northern hemisphere over a very short distance, which doesn't happen that often.
The convergence of these very different air masses was a key factor in forming the intense low pressure system.
You have cold air that's falling underneath that warm air that's going up. And because of the Earth's rotation, we have something called the Coriolis force, a storm system starts to form and spins in a counterclockwise manner. So this storm was pulling moisture from the south as it went to the north.
Like super jet fuel for the storm.
At this point, the storm was behaving like a hurricane, and Bombo Genesis occurred. And this is when you have a very rapid drop in air pressure, which suddenly intensifies the storm.
This is a composite map of what date was the lowest pressure at the surface recorded. And this is of all time for all months. This is the lowest pressure that was observed there as long as records have been kept.
Cold air right here coming in. These lower heights right here will help amplify the storm that's developing over the northern Gulf.
This is intense, almost as intense as we would see with hurricanes. In fact, if this system were a hurricane, it would have been rated Category 2 with the pressure depth and wind speed that we saw with it.
As the storm traveled north, record snow fell across the region.
It's bringing in air at sea level, and that air confronts the mountains, is lifted and cooled. Cooler air cannot hold that moisture that had at sea level, and so it must fall. And it fell as snow because the air was so cold.
But this air wasn't just Alaska cold. It was stratosphere cold, which was due to the polar vortex. And this is a funnel-shaped mass of extremely cold air that usually lives more than 6 miles above the surface of the Earth. And typically it's centered above the North Pole in a circular configuration.
That's what we call a strong state, and the cold air typically stays close to the Arctic region.
But sometimes it can get disrupted or stretched.
And during the superstorm, we had one of these stretching events.
When the polar vortex is stretched, this extremely cold air can break off and move southward. And that's exactly what brought record cold air into the southern and eastern United States.
And that enabled it to get down to 2 degrees in mid-March here, which is still to this day the coldest temperature on record in the month of March. Next time we have a day like that, I'll be at the cemetery.
Our climate has been warming steadily since then, but there's something eerily familiar about the severity and magnitude of this storm.
Well, it's all connected. The superstorm of 93, this extreme cold and the snow we just had in January for that 2-week period, the Texas freeze of 2021, they all have the same mechanism behind them.
And that's what's fascinating. It seems that when this setup occurs in our atmosphere, it consistently overpowers the warming effects of climate change. Cohen published a paper in 2023 that confirms this idea. We'll link to it in the description.
The cold extremes are trending upward.
In this study, he looked at the coldest 5% of each winter from 1960 to 2023, and he broke them up into 3 time periods: since 1960, since 1990, and since 2000. He did this to better understand how winter extremes are changing in 4 mid-latitude regions, but today we're only going to focus on the central eastern US region.
We have found that the most extreme or severe winter weather events in the United States are associated with these stretch polar vortex events. So if you go back to 1960, you clearly see a declining number of these events. But when you look at the absolute temperature, the extremity of the cold, there wasn't a statistically significant difference. You can identify some warming.
Since 1960, there has been a decrease in the frequency and severity of these winter storms, but something strange happened when Dr. Cohen looked at how these extreme cold events have been behaving in the last 23 years since the beginning of Arctic amplification.
Since 2000, you actually have an increase in the frequency of these extreme cold events. And there's actually a statistically significant cooling of the cold extreme. The cold extremes are getting colder.
So although we're seeing a lower frequency of these cold events since 1960 and milder winters overall, since 2000, in the central eastern US region, there has actually been an increase in the frequency. And the coldest 5% of winter events are not warming. These weather events are actually getting colder. So as we forge into unprecedented territory and global temperatures rise overall, global patterns become harder to predict.
Relationship between climate change and extreme winter weather. It's not monotonic, it's not linear. Maybe we need to rethink this. The highs are getting higher, but the lows are not getting higher. So it's just the volatility is increasing.
But I really wanted to know if the storm of the century could happen again.
Am I going to say that Alabama's going to see 16 inches in the next 5 years? I don't know. I can't say that. But I mean, these events do happen all over.
What we need to be prepared for are the extremes that are going to continue to occur. It's the extremes that we are going to be having to accommodate for the rest of our lives.
And this seems to be the common theme as we continue to learn more about our climate systems. Our planet is changing, and though we might not know just exactly how our weather will behave in the future, it's probably wise to adapt and prepare. Because as we saw in 1993, our weather has the tendency to get a little crazy. Anyway, thanks for watching, and as always, let us know what you think in the comments below.